Welcome to the course Deep Learning. Today we are going to discuss an important conceptual idea behind the deep learning is the neural network. And in this lecture especially we have to understand why neural network is so important in playing in the course of deep learning. So here we have given in the graph, let us understand the components that it is mentioned over here. Every, here this one is nothing but this is a feature vector that has been generated from the class omega 1, and these are the feature vector that are generated from the class omega 2. Okay, so here we have two classes. Let's say we have two classes, one is omega 1 and the other one is omega 2. Okay. Maybe we can say that the set of samples that have taken from the apple extracted those features and then it is plotted in this two-dimensional graph. Similarly, we can assume that another fruit, let's say orange, all the samples belongs to the class oranges. Those features are extracted in terms of two dimension and it is represented in this two-dimensional graph. And we can write this as F1 and this as F2, stands for feature 1 and then feature 2. We can extract as many features as we want, but for the simplicity let us assume there are only two features, and every samples that has been taken from the classes has been represented in the form of two feature vector, which is F1 comma F2. Okay, and this is one sample, this is another sample, this is another sample, and there are many samples that are taken from class omega 1, and these are plotted over in this graph. Similarly, some set of images or sample images belongs to the class oranges have been extracted and plotted in this graph. Okay. The existing approaches, so what we want to do given the set of feature vector, we want to have a decision boundary that can classify these two classes correctly. Okay. The very popular approaches that we have already seen, such as perceptron and then SVM, these are assumed that the classes are linearly separable. Fine. So the classes are linearly separable in the sense that we can have a straight line which can able to separate the given two classes. But in this case that we have considered over here, we cannot have any straight line that can able to separate the samples that belongs to two different classes. So here the decision boundary that we can have is not possible to have a straight line which can able to separate these two. Instead, what we can have is non-linear decision boundary. Non-linear decision boundary. Okay. So, the most popularly used non-linear decision boundary is the quadratic classifier, and or at the most we can go for the cubic classifier. The very popular approaches such as perceptron and the SVM, this will assume that if at all the classes are linearly separable, we can have a decision boundary. SVM also works for nonlinear decision boundary also, but in the simplest form, this will work for the under the assumption that the classes are linearly separable. Okay, and so if we can extend even more complicated decision boundary, let us take in this scenario. So here we can have the most non-linear decision boundary is quadratic classifier. But let us have a look at this example. In this example, we can see that the non-linear decision boundary is so complicated, which can able to separate these two given classes, which are all point from the samples taken from the oranges are marked as the red color, samples taken from the banana or some other classes apple, which are pointed as the blue color. Okay, having analytical expression such complicated decision boundary is too complex. Fine. So at the most we can go for the nonlinear classifiers such as the quadratic or cubic classifier, so that we can have a very well mathematical expression to define this kind of quadratic or cubic classifier. Okay. So as the decision boundary become more and more complex, we cannot have mathematical expression which can able to conveniently represents this complicated decision boundary. So in such a situation, people make use of neural network to have a decision boundary which is so complicated, and also we can try to have such non-linear decision boundary. Okay, and one more point is that here we have only two classes. Okay, so class 1 and then class 2. Suppose if we want to extend for more than two classes, then the problem become too complex, and then we cannot able to arrive much convenient mathematical expression to represent this kind of non-linear decision boundary which is so complex, at the same time which can work for more than two classes. For example, if you have 50 classes, 100 classes, having such complicated non-linear decision boundary is become quite complex in case of perceptron and then SVM. Although it will able to generate the linear decision boundary, this is guaranteed that there will be some error, but that error will be as minimum as possible because we follow the algorithm called squared sum of error. That squared sum of error should be as minimum as possible. That can be guaranteed in case of perceptron and then SVM. So in such a situation, as I said, that making use of neural network is a wise decision. So what does neural network do? So what does neural network do? The neural network, in the simplest form, we can say that it is nothing but a collection of